Welcome together into our today's Saturday webinar. As the last week, we are focusing today again with Mohammed, the topic according agentic AI security. Last week we covered the threat modeling approach with Maestro. We showed a little bit about the most relevant risks, also in the real case scenarios out there, from co-pilot breaches or breaches within AWS with coding uh, agents which can produce, of course, malicious or insecure code and so on and so forth. So this is a quick summary from last session. Where we focus more on the risks and threat modeling approaches. And today we want to take this and deep dive further into the security. So how to secure now? We know now the risks. We know how to identify the risks with Maestro, with a 7-layer technique for threat modeling. And we also looked at the high relevant and most relevant threats and vulnerabilities according OWASP Agentic AI Top 10, which we went through, like goal manipulation, like prompt injection, rag poisoning, and all that interesting stuff what we have as a risk on agentic AI systems. Now we want to focus more on how to prevent against these kind of attacks. So this is a core topic today, and uh, and also we want to show at the end of this webinar a quick live demo on FinBot CTF. So it's a vulnerable agentic AI application, and so Mohammed will make a quick walkthrough the CTF, show how the real agentic AI can be manipulated in the end. So this is the topic for today. Mohammed, some additions from your side?
Yeah, and last week the couple of past week, we explained what makes an agentic AI system. We went through the couple problems that could happen to it, from prompt injection to goal manipulation. And then we've talked about the different frameworks, OWASP Top 10 and the Meter Atlas, that constitute the Maestro Sentinel application. And today we are going to speak more about how to secure them to begin with. And then, as you mentioned, we're going to talk about the FinBot CTF challenge and to really see how these types of attacks could compromise our systems and how dangerous they could be.
Yeah, but it's a really nice. I love the CTF, the FinBot CTF. It's a really explanatory, so you can directly see how you can attack, what are the risks, and I mean this is a CTF. It's a demo environment, but this is in the end the same what is out there in the real world.
Exactly, like we've talked about how important these things can be and how easily vulnerable they could be if they're not mitigated properly.
Yeah. And what would be, in your opinion, so why agentic AI has specific risks in accordance to like standard AI system? Why the agentic AI system is a little bit special?
Well, traditional threat modeling assumes relatively stable trust boundaries. So in multi-AI agent system, those boundaries become dynamic because agent can make runtime decision, invoke tools, and trigger downstream actions autonomously. That is why agentic AI security must be modeled as a system problem, not just a model problem.
Yeah.
And
Right. So this is so stride model. I mean, it's still valid because agentic AI systems is also running on standard infrastructures, right? But
Mm-hmm.
in the end, I mean, agentic AIs has a lot of bigger risk landscape which we have to address, and where stride methodologies or other traditional threat modeling frameworks doesn't work properly.
Yeah,
And
and
yeah, also, yeah, yeah,
yeah, and it's quite harder today to mitigate all these problems. Like a couple years before, like you've said, the stride methodology could essentially make you safe. But in today's world, a common language speaker can put you at risk, like we've seen with the Anthropic Cloud model, where a hacker utilized it to essentially hack a lot of companies, basically speaking English, you know, like making a lot of damage with the English language, like without, like you don't need any knowledge about how system works, like you just need common sense
yeah, it's
to,
quite easy, right? Quite easy
absolutely.
nowadays as an attacker to attack and such systems. It's also like a little bit fun, to be honest. In the end, doing doing a testing with prompt injections and trying to trick out the system.
Yeah, like imagine seeing movies back in the day about like Anonymous, and they be wearing code, trying different things, going on site, and now you just need like the English language or your own language per se, you
Yeah.
know, just to make damage. But let me ask you this: so what makes a multi-AI agent system riskier than a single agent or a single LLM application, Valerie?
Yeah, I mean, so a single LLM application, of course, is also already quite risky because you can also like try to manipulate, try to perform a prompt injection, maybe extract some data, sensitive data, right? But
Mhm,
I mean, the threat landscape is quite straightforward. You have your AI system, maybe you have the database behind, and you have a clear attack path. So
mhm,
from the prompt LLM and maybe like the data. But if you have a multi-agent agentic AI system, like a real big agentic AI landscape, maybe you have a marketing agent which is working with a research agent which getting information from the world uh, for the marketing to make more targeted marketing, and then from the marketing maybe you have also some sales agents who are also approaching companies, then creating maybe offerings and so on, so a real multi-agent. So the problem is you have much bigger attack surface
mhm,
because you have a multi-agent. You have so different input parameters and attack points, so to say, right? So you also you have so multi-agents are communicating with each other, obviously, if they want to work together. Then you have also on every communication point between agents a possible attack where you
exactly,
can manipulate the system. And
exactly.
also, it's much harder if you imagine from like AI Act and so on and so forth, from a security perspective. What do you need? You need a proper logging and monitoring, right? So you have to identify and log your AI system. Okay, nice. On one agentic AI system or on one AI system, it's quite easy. I have there my logging, my monitoring in place. I can see if it works. Now we have a multi-agent AI system, so where I can monitor. So and if there something happens, and then the impact is maybe on another system, right? So I have here the
Mhm.
attack on one system on one entry point, but the impact is maybe on another entry point.
It cascades, yeah,
I don't see really where the attack came. So this is also
exactly.
very I would say challenging with agentic AI systems. So that's why it's a very complex threat landscape. And I mean, if you do it like just um, without the proper methodology, like Maestro, it's quite impossible, really,
Yeah,
to
and the more complicated
yes.
and the more complicated you make your system, the more vulnerable you make it. So the more entry points you have, the more the attacker can have ways to get into your system. And if one agent fails, it all cascades. So if one fails, your whole system could fail, you know?
Yeah, and in the end, it's also, I would say, um, not that it's mathematically proved, but I would say it's like an exponential growth of attack paths,
Yeah.
or yeah, attack paths, or like options to attack in the end, options to exploit. Because I mean, you have one prompt on first agent, then you have three more you can use with this. You can also then attack the three more, and then we have maybe behind the three additional agents like other systems. So you have like an exponential growth of the attack paths based on the numbers of interfaces of agents. And then behind, what is also very complex, is to oversee all the permissions what we have. So every
Hmm.
agent needs some permissions to operate, and this is like the main reason for an agentic AI, right? It has to do some work for you, and to do work
Hmm.
for you, it needs permissions, and to oversee the whole permission landscape for the multi agentic AI landscape overall. It's yeah, very hard to tackle this, and it's absolutely necessary to have a proper threat modeling approach to identify the most relevant threats. And I would say that you can easily have like hundreds of threads overall with a small typical subset of agents. And then you have to look what are the most relevant risks. So where you have a high autonomy, where you have a critical decision point of your agentic AI system, right? And on that point,
Hmm.
you have really to dive into security. That means to look what controls do we have here, and also if we have our controls designed and implemented, it's very necessary in the next phase to test also the effectiveness of the controls,
Exactly.
because I mean, you can make good prompt injection prevention techniques and optimize your prompt, optimize your system prompt, make it harder and everything. But then you have a problem with the permission somewhere that didn't check it properly. So it's very important not only to do threat modeling and design the controls in the architecture and implement them, but also test against them, test it properly, because it's with AI, it's like completely not deterministic. So you can't never
Exactly.
say, you can never say it's now really secure. You can't. You just can't.
No,
Just say, I think the security is quite good here right now, but do you know this really? You don't know if you don't test. So that means you need to perform a proper pen test, which has a freestyle approach with a red teaming approach, like red teaming of agentic AI systems, to really know if the controls are hard enough. And this is in the end also the topic of the skills of the pen tester. So if the pen tester skills are good for prompt injections, then you also test your security controls, your security safeguards good, right? But if the skills are not good, then I mean also the pen test is not very comprehensive, and it's yeah, very hard in comparison also to traditional systems to perform a good pen test. So the skill requirement for pen testers are much higher, in my opinion, because it's also more
exactly.
not deterministic. It's more freestyle. You don't have regular expressions from the prevention. You can't do like typical input validation, whitelisting approach. Okay, I have here a field email address. I know exactly how the email address have to be built, and I don't accept any other text strings there. Okay, quite easy. But with the prompt, you can you can prompt what you want. You can't do classic input validation
Yeah,
or whether blacklisting or whitelisting. You can't do both. You are completely dependent on the system prompt on other controls. But we will discuss this later. So yes, you can talk like hours about this topic. You see already.
exactly. Yeah, there's a lot of gaps that could compromise our system. So we have to be ready for most all of them. It's an ever-going problem with an ever-going like surface to really mitigate these problems. So.
Yeah, yeah. And about the OWASP agentic AI top 10, what would be like just as a small quick recap? What would be yeah, the most relevant stuff out there?
I would say OWASP's top 10 for agentic application really identifies the highest impact risks for autonomous and agentic system. What this tells us is that the risk picture has moved beyond classic prompt injection alone. So the dominant concerns here now includes misuse of agency, excessive permissions, poisoned memory, unsafe tool execution, insecure agent-agent interaction, and a lot more, like failure propagation across autonomous workflows. So
Yeah,
in
yeah.
reality, like, mhm,
Yeah, so the autonomous workflows, this is exactly where the highest risk came from, right? If you have an autonomous workflow, you have to really take care about human in the loop here. So if it's necessary, and then also, I mean, we will see it later in FinBot. So human in the loop. If the decision
it's a
is also
decision. Yeah,
relying on the AI, right? So whether I
yeah.
have human in the loop or not, if the decision is also relying on an LLM, you can also attack and bypass the decision process about human in the loop. Or you have no option. You have technically, in best case, depending on to what your use case is, you have technically enforced the human in the loop in the chain. So, but in the end, then you have no autonomy, right? So, if you have technically enforced human in the loop, then you don't have, per nature,
Mhm,
a full autonomy. And this is like
mhm.
what you have to, this is about risk management. So, is it acceptable from this perspective to have autonomy, so without human in the loop, or not? And then, then there is
That's the
this
dilemma. Yes,
the balance to find a good balance between security and efficiency in the end.
autonomy.
So
Yeah,
the maximum efficiency you get from agentic AI if you have a more autonomy, right? So, but in the end, it's also then quite risky. So
absolutely,
very interesting
absolutely.
topic. Yeah. Yeah. So about prompt injection, I mean, we have already discussed the threat modeling approach, Maestro. We also discussed, right? And uh, I mean, now I would say we can the security so what we discussed at the beginning. I mean, as a summary, we can say agentic AI security is no longer only about protection and unsafe output. It's also about all risks according the goals of the agentic AIs, their memories, the databases of agentic AI, and here we have a quite good, I would say, knowledge base uh, from OVAS to with a 10 to really identify the most relevant risks out there. We have a really nice methodology with a Maestro framework which we could use to tackle this big problem here. And yeah, I would say let's now dive into the security controls. Or do you have some additional words before we dive into?
I think we should probably save this for the presentation that we made, like the best practices to secure our systems.
Yeah, all right. So then let's now share the presentation. All right. So we have now. the presentation in front from us. So best practices about securing AI agents. Mohammed, it's up to you.
So securing AI agents ensure AI automation safety across enterprises environments. As these agents become more deeply embedded in business workflows, organizations must adopt proactive, multi-layered strategies to protect them. So among these key best practices to secure our systems, designed to protect enterprise systems while maximizing their potentials are the main idea is that if the MCP acts as the bridge between agents and tools, we need to treat it like a serious production interface. First, we ensure a safe connectivity, prefer local STDO or Unix connection, and if remote, use TLS. Second, we enforce a strong session isolation by separating memory, temporary files, and execution per session, so data doesn't leak between sessions. Third, we allow only authenticated clients using allow lists, uh, MTLS or OAuth for dynamic clients. Fourth, practice lifecycle hygiene, wipe sessions artifacts on timeout or disconnect to avoid leftover data persisting. Fifth, implement strict message validation, check the MCP JSON RPC schema and reject unexpected inputs. So only well-formed messages are accepted. And finally, we apply the blast radius limits with per session quotas and API rate limits to prevent abuse and limit potential damage. Uh, the second best practice is safe tool design because tools are where an agent's intentions become real actions, like we previously discussed. So there are four main points here. First, we use signed manifest chip, a signed tool identity that includes version, schema, and permission, and verify the hash to ensure you're running exactly what was approved. Second, here we make sure description equals reality. So spot on checks, tools to confirm their behavior matches what that they claim, and flag any unexpected actions. Third, we enforce controlled onboarding. New tools shouldn't just appear in production. They should go through an approval workflow, automated scans, and a security review before being allowed.
Yeah, so
Fourth,
in the end, a proper development life cycle also, right? So here, so we have if you develop new capabilities in our agentic AI, we have a proper workflow. So a security gate model, so typically is best practice, so that you have, for example, if you have performed threat modeling using Maestro, you put in the controls from your most relevant threads in the security design of your agentic AI system. Then in the development phase, you like have your scans like static code analysis, right, or
mm-hmm,
dependency checks, so you know exactly what components are vulnerable. If you have insecure code out there, maybe in addition perform a pen test. I would even say, especially for big major releases, if you have a big upgrade, a pen test is absolutely necessary here as a security gate before you go into production. So this is, I would say, is quite critical here. And yeah, otherwise, of course, if you go and then approve and go into production, you have also to have a proper monitoring then in place. But yeah, go on, Mohammed. Exactly, this is my opinion, the most critical points here.
yeah, exactly. I absolutely agree. Moving to the data validation and resource management. Like the theme here is controlling both what goes in and out of the system and how much an agent is allowed to do. That's basically the whole point here. So we first enforce resource limits, use per session quotas, and timeouts to prevent runaway tasks so an agent can't loop endlessly or consume unlimited resources. Second, sanitize inputs by stripping dangerous sequences and reducing injection risk like SQL, XSS, or command style payloads. Third,
Yeah.
we
Yeah, so
enforce a strict.
here, cross-site scripting, I also saw this last time somewhere. I don't remember exactly which application it was, but cross-site scripting attack also. So if you just prompt something with a cross-site script, right? So and then if the output encoding is not implemented properly, you can also execute JavaScript. So this is all, and of course, the classic attacks, SQL injections also are valid here. And even you can do like not only the classic SQL injection, but also like a LLM based SQL injection. So it
Mm-hmm.
means not like select blah, 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 star wildcard from table or drop table blah, blah, blah. So the classic SQL injection commands, but also via prompting, right? So you can also maybe execute SQL queries if
Exactly.
if the agent is capable of executing SQL queries.
Mm-hmm. So here, third, we must enforce a strict schema, like you said, for input and outputs, JSON schema for tool I/O, ensure the system only accepts structured expected data. Fourth, we set a hard size bounds, limit the size of inputs and outputs to prevent payload abuse or system overload, like DDoS. Uh, Fourth, moving to the prompt injection controls. Here we have four main controls. First, we use structured tool calls, schema validated JSON calls to prevent agents from smuggling unsafe instruction through free-form text. Second, run an independent policy check. A separate policy reviewer can explicitly allow or block tool calls and their parameters. Third, we enforce a human in the loop approval for irreversible actions like deletes, payments, or critical changes, so a person confirms before executions. Fourth, we compartmentalize context, keep sessions separate, one task per session, and reset context when switching tasks to prevent instruction from one task bleeding into another.
Hmm.
Um, yeah.
Yeah, this is also a very interesting point. So the context. So as we know, LLMs is really relying on context, and like resetting the context here and there makes absolutely sense. And if I put this into the um, OWASP top 10 again. So
Mm-hmm.
it's about the gold rift, something like that. So you could have a gold rift. So if your agentic AI system is working for a long time and then always manipulating a little bit, so you have not just a really hard prompt injection out there, but only a small prompt injection, which is
Go
quite
through.
which
Yeah.
is quite good looking for the AI. So AI doesn't identify it as a prompt injection attack. And but if you do it like 10 times a day or 5 times a day, and then after a week it sums up, and then you have a really big goal drift already out uh,
Yeah.
really reached as an ethical, right? So you can be very, it's like the in a classic pen testing approach, you can pen test loud or quiet, right? So you can pen test like, oh, you scan all the systems, try to exploit everything, and be really loud. But then the problem is the CM
You get
systems.
caught. Yeah.
Yeah, you get caught, right? So all the
Exactly.
detection mechanisms identify your attack. And same here. If you are loud, if you do hard prompt injection attacks, maybe you it will identify it easily. But with small things,
Small
um,
changes. Yeah.
or small changes over 1 week, or even longer. So this is like about a little bit like red teaming activities. So in red teaming, you don't you also try, like it's not like a scanner out there. You scan and then okay, done, checks done. But you really try hard for a long time to reach your goal. Like for example, a goal drift. And if you use context reset, this is the most relevant mitigation against this goal drifts for long period of attacks, of small prompt injection attacks, so to say. So this is a very critical mitigation technique, which should be
Yeah.
considered. Yeah.
It might be small or but it really does work. You know, it could
Yeah.
really like help your system stay protected, like even
Yeah.
though you don't see it clearly.
Yeah, of course, only if it's possible from business perspective point of view, right? So sometimes you
Exactly.
also need context to properly work, but if you are able from business perspective to reset, then just do reset.
Hmm. Moving to our fifth best practices, authentication and authorization. Basically, here we ensure that the agent and its tools only do what they're allowed to do. Here we have five key points. First, we use OAuth or IODC everywhere, authenticate every request, and verify the issuer audience, signature, and expiry. So requests are always verifiable. Second, we use short-lived tokens with minimal scopes and minute-level lifetimes, and we check before sensitive tool calls to prevent any lingering access. Third, we delegate safely, maintain the service's own identity while enforcing the user's permission, so it's always clear who is acting. Fourth, have a central policy gateway, OAuth in, OAuth Z, consent, tool
Mohammed,
filtering.
just one quick question. Maybe we need to go to the next slide for the points, or because there was only one item added when you moved on to the next slide. Can you double check this quickly?
I
We are
don't.
still in the authentication and authorization slide.
Yeah, yeah,
It's right?
yeah. It is.
Okay, okay. Now then it's good. Just wanted to double check.
Yeah. So fourth, uh, have a central policy gateway for OAuth, OAuth consent to filtering and audit logging, keeping policies consistent and centralized. Fifth, never pass client tokens downstream. This prevent the confused debit problem. Okay, can you see? Yeah.
Yeah, yeah. Now I see. Okay.
So the sixth best practice here, secure deployment and updates, making sure the way we ship and operate agents is production grade. There are six areas here to focus on. First, secret management. Store credentials in a vault and never put them in environment variable code or logs. Second, supply
Yeah.
chain
So the
security.
maybe a quick thing to the secrets management. So this is I would say also a quite common challenge what the companies are facing. I mean, the secrets in the code are almost out right now, so very rare right now happens, but still in the environment variables or in the config files, and then we have to be really careful where to distribute your repository. So and change key rotation is now it's very hard. Yeah, so key vault, like whether it's a cloud based like Azure Key Vault or AWS Secrets Manager, or on-prem solution like HashiCorp Vault, it's quite critical here. Also to manage properly your secrets, especially if you have, like most companies have, like also external developers, so that then you don't have the transparency where my secrets are leaked,
Mhm.
right? And yeah, so this is a very important point, secrets management.
Yeah, exactly. I totally agree. Moving to supply chain security, pin and scan dependency. We can use signed images, track CVEs, and maintain an SBOM or a bomb, so you always know what you're running. Third, hardened runtime. We use minimal non-root containers, drop unnecessary Linux
Maybe
capabilities.
quickly to the first point. I read it was yesterday about, or before yesterday. It was about before about the new Trivy attack. So Trivy, maybe
Mm-hmm,
you know, it's the container scanning, yeah, open source tool.
mm-hmm,
So you can use Trivy to scan open source with this open source solution containers for CVEs. So it's container scanning. So for example, if you have a Kubernetes cluster with yeah, images within your containers, and all these containers you can scan for CVEs, like if there is, for example, a CVE on your web servers, on Nginx or Apache or something like that, you can scan it with Trivy, and or you can also scan images and all that stuff. But Trivy itself, so the security scanner, was compromised.
Really?
Yeah, so even you can have problems if you try to include security in your CI/CD pipeline with, for example, Trivy, but Trivy itself can be a problem
Can
if
be
there is.
compromised,
Yeah,
yes.
it's the and Trivy has been compromised, and yeah, so this was here on 19th of March, I see. Yeah, 19th of March, 19th, so it's 3 days
2
ago.
days ago, yeah.
3 days ago, the attack occurs on Trivy. So it's who is using Trivy out there? Please check it.
Yeah, it's really hard to really maintain like security. Like you can trust someone with your own data, but they're also susceptible to being compromised.
Yeah, yeah. So this what was to this point. Software supply chain
Yeah,
is
that's
critical.
interesting.
That's why you need an SBOM, so software bill of material, but also AI bomb. So about your AI stack, right? So what are your LLM models? Which racks are you using? I mean, typically you don't reinvent your software, but you also don't reinvent the LLM, right? So I don't know. How many people are developing their own LLMs? I guess not so many. So of course they're also relying on existing models, on existing AI components, and that's why also for AI security here we need a proper AI bomb. If there is a problem out there in an LLM, yeah, right. So there is a vulnerability or an attack in an LLM, and then you have also to know if you're affected or not.
Exactly, yeah. Moving to our fourth line, CI/CD security gates. We should block builds if there are vulnerabilities, unapproved dependencies, or policy violation. Here we have OPA as an example. Fifth, network segmentation. We can use restricted segments with deny by default inbound and outbound rules like Kubernetes network policies. Six, safe error handling. Do not expose stack traces, tokens, file paths, or internal tools details in error messages. Like anything like you put to per se to the public can really put you at risk.
Yeah,
So
it's a classic control from classic, yeah, security, we can say. So safe error handling is always important. But
yeah,
we see here so many stuff. Or on this slide, all is applicable for non AI systems as well, except AI bomb, of course. But everything
hmm
here is also like classic security. So classic
yeah,
security is still
it's
applicable.
always there. Yeah,
That's why also like traditional threat modeling using Stride is also applicable. It's just that with AI you get new challenges, but it doesn't mean that the old challenges are out out of visibility for the security experts. So you have still to take care of.
yeah. It's an evolving problem. So like everything from the past is still applicable today. Classical security measures are necessary, but we have to evolve with our new attack surface and see how we can harden it as well.
Right, right.
That leads us to our seventh best practice, governance and auditability, making sure we can trust what tools and agents are doing and prove it after the fact. There are four key elements here. First, cryptographic integrity, sign and pin tool and dependency versions to prevent silent swaps and detect any unexpected changes. Like we mentioned before about goal manipulation.
Hmm.
Second, here we have trustworthy audit logs, log every action and its parameter, redact or hash sensitive data, and store logs immutably so they can be altered later. Third, security peer review. Require a security focused review before onboarding new tools so decisions aren't just functional. Fourth, non-human identities. Treat agents as identities with unique credential, least privilege, and continuous audits, governing them like real actors. And building a multi-layered security approach. Here, deploying isolated security controls requires a multi-layered defense and depth strategy that combines redundancy, organizational preparedness, and seamless integration with existing security infrastructures. Below, we will walk through the three critical pillars of this approach. First, we use a defense in depth strategy. The main message here is that we don't rely on a single control. We stack multiple of them to detect, prevent, and contain threats at different points. First is layered controls. These safeguards should work across the network, the application, and the data, covering the full surface that the agent interacts with. Below that, redundancy and resilience. The idea is to avoid single points of failure. If one control fails, others still provide protection. In the middle, the visual shows the agent at the center with layer around it, data, application, and network. This illustrates where controls can be applied closer to the agent or further out in the environment. To the right, for the continuous improvement, we run attacks simulation and update controls over time because threats evolve and defenses must evolve with them.
Yeah, this is a very good one. So defense in depth strategy. It's also a very I would say common and traditional approach. It's also very critical here. I would say even more important for agentic AI security. So because you have here like just an additional layer which you didn't had before, the AI layer in the end. Uh,
Mm-hmm.
all the traditional layers, according defense in depth, they are still valid, like organizational controls, technical controls from network, perimeter network, application, services, data, still out there, but you have now, so to say, an AI layer in addition. And so this is the agent here, what you have on the picture. And yeah, you have just one more layer, and every layer should be secured. And imagine, for example, you have a safeguard, so a built-in safeguard. Okay, it's nice, it protects against some malicious stuff, but for your business case it's mostly not enough. You need like an own custom safeguard which protects against other kind of attacks uh, which are outside of the business purpose of your agentic AI system, right? And
Mm-hmm.
also, this like existing safeguards are sometimes not very effective, depending on the model what you use. Some are effective, some are less effective, and yeah, that's why it's very important here to look at defense in depth about different layers
So,
to really protect against it properly. And for example, data, if you have you protected your prompt really good, but there is a security issue which leads to a manipulation of the RAG, right, of the vector
yeah,
database, and it's all is lost in the end. And this is exactly what is to be looked at with a methodologic approach, Maestro,
mm-hmm.
to identify threats layer by layer.
Exactly. Which leads us to our next point, organizational readiness. Like shifting focus from technical controls to organizational readiness. So here, like the problem, you have to have all aspects of security, whether it's technical or non-technical. Okay, even the strongest architecture still needs a human and procedural alignment to be effective in practice. First is team preparation, train security in IT teams on agent risks and treat agents like privileged service accounts because they can have powerful access and automated execution. Second is policy and governance, focusing on lifecycle policies, how we deploy, monitor, and decommission agents, and making sure incidents response process align with that lifecycle. Clear rules for managing agents from start to finish are also essential. Third is vendor evaluation, assessing third parties for controls, certifications, tenant isolations, and auditability. If we rely on external agent tooling or platforms, we should treat them like any critical vendor. Like uh, I've read the other day about like certain models on Hugging Face, how people can alter them or publish agents malicious, and it would bypass the security measures put by the Hugging Face team, and it could be downloaded by multiple people and no one would know,
Mm.
and even deployed in companies.
Yeah,
So
sure. Yeah, so it's in the end not depending on the exact framework what you're using. Every framework
yeah,
has different weaknesses, right? And this is also in the Maestro framework. So that's why it's so good to use it. So because you see, okay, now you're on this layer about the framework of your agentic AI system, and you can see, okay, I have Hugging Face. What are the most relevant weaknesses in Hugging Face? And for example, you have an LLM model which is highly vulnerable to hallucination. Then you have to take care about more about hallucination problems and so on and so forth. Some are more vulnerable, some are less vulnerable. And this hallucination topics, by the way, it's also yeah quite critical one where you have also to include this organizational readiness and maybe here one quick thing also you mentioned here team preparation, so it's like yeah training them on risks, on controls, and so on and so forth, and also provide proper access control concepts. I would say here is a very good one is that you have in your team structure, org structure, in every team who is also doing AI stuff, AI development, and so on and so forth. You have a security champion, so he can bring up security into the team properly. So because typically we are coming from the infosec department. Let's say like CISO is taking care about security, blah, 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 as a central department, but it's really necessary to democratize the security in the whole organization.
exactly,
But it
yes,
is much easier if you have in your different departments and teams also a security champion who brings the security topics in the teams and takes care that the security requirements, controls, and also the awareness is yeah raising properly in the teams. And then you can, as a central security team, the security department, like the CISO, he can organize a regular session with the security champions to perform knowledge transfer, right? So that the security champions are also updated and trained properly, and then bring their knowledge into the teams. So this is a quite critical one from the organizational, yeah, approach and
yeah.
readiness.
What I want to add on that is like security should be introduced from the beginning, like from the data collection to the model training, all the way to implementing it and monitoring it. So the whole team should be aware from the for the risks that could be susceptible to our system, you know, which
Yeah,
lead
100%.
yeah, which lead us to integration with existing security infrastructure. Like the main message here is that the agent security shouldn't work in isolations. It needs to fit smoothly into the organization's existing system so everything works together as one defense. The diagram here shows an agent security layer as a hub with the main integration points around it. On the left, you have SIEM integration, feed agent logs into your SIEM to enable correlation, authoring, and incident
What
workflows.
what I want also to add here, if we are talking about SIEM integration, so what is really necessary here is to, it's absolutely necessary. It's not possible with a traditional CM system anymore to detect and react properly to AI attacks. It's just not possible. You have to implement also AI into your security stack. Otherwise, you have no chance to identify properly, for example, a prompt injection attack. How you can identify a prompt injection attack with a traditional CM system, which works based on regular expressions, based on hash sums or whatever. So, how they build up the use cases for the detections, these use cases from traditional systems like a Splunk CM or Azure Sentinel, all the traditional built-in stuff you can't use for your agentic AI system. So it's completely blind. It's just for the auditor you can say, okay, I have a CM system, check. But to be honest,
That's not enough. Yeah.
it's not effective. The traditional CM systems are completely useless if they are not using AI to detect and prevent. They're completely useless for AI security. So you can completely like I mean, of course, for traditional attacks they are still valid, but for AI attacks, you can
They're
forget
not
your
enough.
system.
Yeah.
You have to make your security stack, including CM, AI ready. So you need a proper upgrade of your CM architecture if you have AI. This is a very
Hmm.
critical point here, what I want to add.
Yeah, absolutely. I totally agree. Uh, CM alone isn't really effective anymore, so it has to be integrated with other systems that could help with the protection of our AI agent workflow. So we've also need IAM alignment, treat agent as non-human identities using airbag or ABAC and zero trust policies. So agents follow the same identity controls as the rest of your environment. To the right, we have compliance, align deployments with audit, privacy, and regulatory frameworks across the organization. That's it for our presentation. Whether if you have anything to add before we move to our CTF.
Yeah, great, Mohammed. Thank you very much. As we are right now almost in 1 hour session, I would say it was a quite interesting discussion. Um, let's move the FinBot CTF to the next session, I would say.
Ah, yeah, sure, we can.
So I mean, we are quite long here. Don't want to overdo it on this. Yeah, great weekend, great Saturday here. So it is in Germany. It's very good weather here. So thank you very much. I would say we just move the FinBot CTF live demo. So a little bit deep dive and practical approach in the next session. So next weekend we will so stay informed. We will create the event as always on LinkedIn Live and also post and getting live on YouTube as always and putting the video on our YouTube channel VamiSec. So to not overdo it in one session. And also, like Mohammed, for you to enjoy your weekend. Thank you
Yeah,
very much. Thank you very much.
thank you so much.
Thanks to all. Yeah, thanks to all. It was very nice. Very nice session again. I enjoyed it. And yeah, see you next time.
See you. Goodbye.
Bye.